Hello, everyone. Welcome and thank you for joining us for Teledyne ISCO's October Water webinar. Today's webinar is focused on Ask ISCO vacuum samplers. This webinar is being led by Steve McManus, one of Teledyne ISCO's product support specialists. If you have any questions or comments during the webinar, please utilize the chat function within the Zoom platform, and all questions will be answered at the end of the presentation. And at this time, I will turn it over to Steve.
Thank you, Tori. Good morning, everyone. It is a pleasure to be in front of everyone here, and I hope we have the next 45 minutes or so to be very productive and answer everybody's questions that pertain to vacuum samplers. If you have questions, please submit them as you have them. If they pertain to the subject matter at hand at that moment, I will jump in and answer it. If it's a subject that relates to something that's going to be covered a little later, I will defer that question at that point in time. And then at the end, I'll try to cover as many questions as I possibly can before we end the presentation. And I will also be providing answers to all the questions via email after we're done, so that no question goes unanswered. As Tori indicated, today's subject matter is vacuum samplers, and there was a variety of questions received in advance, and those are the questions we're going to start out with. But before we get into the questions, I want to get into a little bit about the method of operation of the vacuum samplers. There are two types of vacuum samplers that Teledyne ISCO provides. The first model is the CVE, which utilizes detection of liquid in the chamber, and then the way it takes its pumping cycle is it begins by doing a purge by pushing air out the line to remove any liquid that may have migrated up the line since the last sample, so that when it does pull a sample in, it's fresh and representative of the constituents in the flow at that moment in time. Once the purge cycle is complete, it switches the solenoid and begins to pull the sample in to fill the chamber. Once the chamber fills to the point that the fluid in the chamber contacts the electrodes at the top of the chamber, it stops the fill cycle and begins to purge again. And there is a tube that you adjust vertically to determine the amount of liquid that is going to be delivered to the bottle. So once the liquid is dropped below the inlet to that tube in the chamber, no more liquid will be pushed up and out the tube, and the fluid remaining in the chamber is the fluid that will be delivered to the bottle. So the pitch valve opens and dumps the water that has been collected into the chamber into the bottle below. The second methodology that Teledyne ISCO vacuum samplers use is the QLS method, which utilize a load sensor to weigh the water, and that's how it controls its volume that's been configured to be delivered. The first part of the cycle when it goes to collect the sample is it does nothing other than weigh the chamber to take that out of the equation. Once that particular portion of the cycle is completed, it also will do a purge to remove any liquid that has migrated up the line since the last sample. Once that is completed, it begins to pull the sample in. It switches the solenoid valve to put a vacuum on the line and draw a sample in. Once the load sensor has detected the amount of water in the chamber equates to the volume that you have asked to be delivered, it once again will do a purge to remove any liquid that is in the line at that point in time, thus leaving only the liquid that is to be delivered to the bottle. For each sample cycle, the QLS does a self-calibration check to ensure that it is accurately delivering the volume that has been programmed. So it will do nothing other than weigh the sample in the chamber to determine if it's accurate. And if there is a little too much or a little too less, it will implement adjustments for the next sample cycle to continually improve and become more accurate with each sample that has been collected. Once that is complete, it will open the pitch valve and dump the sample into the bottle below. So those are the two methodologies that Teledyne ISCO offers. So now we'll move into the questions, and there were a couple of different categories that these questions fit into. And the first section of category for questions that came in dealt with application type related questions. And both questions are related to one another. The first question was, do you offer any sampler system for an explosion-proof Class 1 Div 1 environment? And a related question is, when will you get it CSA approved for Canada? CSA is the rating that is the equivalent of the Class 1 Div 1 here in the U.S. for Canada. Both of these questions relate to samplers, equipment in general that can be used in an application area environment that has been rated as a hazardous or an explosion potential environment, and thus this requires a greater design intent into the equipment itself to reduce the spark potential to avoid any potential ignition. Teledyne ISCO does not offer a sampler, including the vacuum samplers at this time, that are rated for Class 1 Div 1 or CSA. In many cases, it is actually best to install the sampler outside of the rated area, run the intake line into the rated area, and this addresses not only the application requirement of the IS or CSA rating, but also there are some personnel safety reasons that are met by not requiring the individuals to enter into the hazardous environment. So this makes a lot of caveats of this type of an application simpler and safer. If the sampler is mounted outside of the environment, there is no requirement for it to meet the CSA, and having the tube into the environment means that it is able to operate in that environment without any problems. The second category of questions related to maintenance. The first question that was submitted were, are there any tips for cleaning the sample discharge chamber without removing it? I will say up front that removing the chamber and thoroughly cleaning it in that manner is by far the best method to guarantee that you're going to have a sterile intake chamber that is not going to potentially contaminate and induce constituents into the sample delivered to the bottle from previous samples. However, you could try flushing the system with a warm soapy water solution, and then follow that by a distilled water and thoroughly flush the system by taking multiple manual samples. I will add that the CVE model is potentially going to require that the chamber is removed and disassembled for cleaning, simply because those electrodes that are there to detect liquid, if they become fouled, material builds up on their surfaces and it fails to detect the presence of liquid, we could place the system at risk. And those risks could range from inadequate sample delivery to or all the way up to system damage if the unit continues to pull liquid in and is unaware that the chamber is full. It could pull water into the pump system and cause some problems. That is not going to be as big of an issue with the QLS. The question that relates to maintenance, calibration, signal voltage checks, replacement parts, and maintenance schedule is also related to the question of how do they operate, which I already covered, but the regular maintenance and frequency. First of all, maintenance. A lot of this will vary from location to location, depending upon what is in the sample that's being collected. Certain materials are going to be more prone to collecting and building up in the system than others. Another caveat to consider is what's the critical nature of what and why are we sampling for? If we're sampling things down in the very minute detection range, it becomes even more critical than ever that that chamber, the line, and so forth all be cleaned, because you do not want residual to be collected up and delivered to the sample bottle and cause false detection in your sample analysis. As far as voltage checks or signal checks, there's really no need to do anything on a regular basis for checking that, unless we have a problem that we are trying to track down and take care of. As far as replacement parts, excluding expendable items such as the bottle and the tubing and so forth, the chamber would be the most likely need for some regular replacement. And I often will recommend that folks do order a spare chamber so that they have one on hand, so that when it becomes time to clean the chamber, we can take the spare one that was on the shelf out, swap it out, put the sampler immediately back into operation, take the chamber that was just removed, clean it up, and then put it on the shelf so that the next time that particular maintenance routine is required, again, you go to the shelf, take that chamber off, go out, swap it out, and this minimizes the downtime for the sampler itself. We have some general questions. The first question, are they more reliable than peristaltic pumps? That's a very difficult question to answer, because it kind of relates to the second question here related to durability. Do they have the same lifespan as peristaltic pumps and samplers? A good rule of thumb is if you take care of your sampler, it will take care of you. If you do the regular maintenance requirements, keep your eyes and ears on the unit, and if you notice some odd behavior or things don't sound right or whatever, don't ignore it. Take care of it right away. Don't position the sampler in application conditions that are going to be extremely rough on it. Example, refrigerated samplers, don't put them in an environment where there's no venting, a lot of excessive heat buildup, and so forth. That will allow the sampler to have less stress, and therefore it will take care of you and last longer. I would say, as far as the durability and the reliability of the peristaltic versus the vacuum sampler is on par with one another. I don't see any advantage of one in the long term over the other, as long as they're well taken care of. What is the difference, if any, from a vacuum sampler compared to a GLS or sequential sampler? There's a lot of issues in that particular question. First of all, a sequential sampler is an indication of a sampler that has multiple bottles. A vacuum sampler can utilize multiple bottles, just like a 6712 or a 3700 or a 5800 sampler. So for all intents and purposes, there really is no difference between a vacuum sequential sampler and a peristaltic vacuum sampler. A GLS sampler is a composite sampler. A vacuum sampler can also be configured for a single bottle, so it too can be a composite sampler. The term composite or sequential relate to the bottle configurations, not the method that the sampler uses to deliver sample to the bottle. There are differences between all sampler models: GLS, 5800, 6712, 3700, 3710, the Optima, the Century 3000 vacuum samplers. All of these samplers have different functions and features that should be considered when determining the needs for a given application. Some of those sampler models have greater capabilities, more complex functions and features that may be required in certain applications. If these functions or features are unneeded, then we can use a model with fewer capabilities. If you need them, then we need to look at the models that have the more advanced capability. Question was submitted indicating that we're looking for basic education to assist with product selection. This is a very common position that I find myself in when customers call in asking about what model, what unit that they require given their application. And the first becomes an exercise that actually has nothing to do with looking at the product. It's more a function of taking a look at what factors, what requirements, what application conditions are we going to be faced with in the application that we're going to be operating under. What do we need the sampler to do? Are we going to be taking multiple bottle samples? Or are we going to do composite single bottle sampling? Do we need to do time-based sampling? Are we going to do flow-paced sampling? Do we need to do triggered sampling? In other words, we're waiting for certain events to occur before we kick the sampler into operation. Are we doing event-based sampling? In other words, we only want to sample or collect a sample when this happens, whatever this is. Do we need to do things like non-uniform time sampling? Do we need to do multiple bottle composite sampling? Do we need to do variable volume based upon conditions that we're monitoring like flow? What are the application conditions and requirements? Is there AC power available at the site? Or do we need to look at battery-powered systems? Is this an environment that has an outdoor, in other words, it's going to be faced with all the elements? Is it going to be indoor? Are we sampling in an application condition that is subject to corrosive gases? What's the length, the distance between the sampler location and the source that we're sampling from? What's the vertical lift from the surface of the water to the position of the sampler? Do we need to get reports out of the unit? Do we need to have interface with other parameters such as pH, temperature, conductivity, turbidity? Do we need to have telemetry? In other words, do we have to have the need to be able to remotely access that sampler and evaluate current status, possibly make some changes in the program? These are all caveats that need to be considered before we begin looking at certain products, because that's going to allow us to determine what products we can rule out versus what products we have to consider, and then we can begin to narrow down what options we should select for that given site. There was a question about wanting to do a comparison between the E&H vacuum samplers to the Teledyne ISCO vacuum samplers. I can't necessarily comment with a lot of knowledge based upon the functions option by the E&H because I'm simply not as versed in that particular sampler model from a function feature set. But there certainly are some performance advantages that the Teledyne ISCO sampler has over the E&H sampler. The E&H sampler sample accuracy delivery begins to peel off with lifts that are greater than 12 feet, whereas the Teledyne ISCO vacuum samplers are able to maintain that plus or minus 5% up to lifts of 23 feet. So we are able to more accurately deliver sample across a wider range of vertical lift. We're able to also maintain the recommended line velocity of 2 to 3 feet per second up to lifts of 23 feet. The Endres Hauser sampler models are not able to meet that up to 23 feet. The E&H sampler models utilize the volumetric method of operation only. Teledyne ISCO vacuum samplers can utilize both the volumetric CVE or the load sensor, the QLS method of sample collection. There is one functions or feature set that the E&H samplers have that the Teledyne ISCO vacuum samplers do not have. The E&H samplers have a USB interface, and they can support a modem. However, if you get down to brass tacks, in most basic sampler operations, the need for a USB interface or a modem is really not that critical. Well over 90% of all samplers that are deployed out there, both permanent and portable, do not have a modem interface on them at all. And with that, I'm going to open up to the questions that were received.
Yeah, we got a few different questions that have come in here. First question being, are there sampling units that have two sample chambers on one unit?
Teledyne ISCO did offer or does offer a dual vacuum sampler that is essentially two samplers in one. Both sides can be independently programmed, time or flow. You can have one be single bottle composite, the other be sequential. You can have both be sequential, multiple bottle. You can have both be single bottle.
Another question that came in here, does Teledyne ISCO refurbish or rebuild the refrigeration units?
We do repairs on units. There is certainly a threshold that can be met in certain cases where it just becomes economically not feasible to continue to repair, and it becomes more feasible to replace the refrigeration units. But there is some level of refurbing or repairing the refrigeration modules that can be conducted.
Would a vacuum pump work better for deeper locations than a peristaltic pump, specifically 20 to 30 feet deep?
As far as depth is concerned, I'm going to take both forks that this question can possibly go down. First of all, we could be talking about lift, meaning the vertical distance from the water surface to the level of the sampler. When you begin to get up to that 23, 24, 25-foot lift, the peristaltic style samplers will begin to peel off on their accuracy for what they're able to deliver, as well as the line velocity. The vacuum sampler is going to be much better at maintaining that line velocity and sample volume delivery accuracy at those greater lifts. Now, if we're talking about we have the intake line 20 or 30 feet below the surface of the water, we're in a deep water application, the differences between the two is going to be minimal. That 20 to 30 feet below the water surface, there's not going to be any advantage of the vacuum sampler over the peristaltic style sampler, because for all intents and purposes, the water itself is going to push that water up that submerged depth, and then the sampler is going to lift it the rest of the way. So when you get down to the bottom line there, the most important factor regarding depth or lift, in this case, is truly lift, and that would be based upon the distance between the water surface and the position of the sampler pump.
How is the CVE 16 set up for flow proportional sampling?
The CVE 16, and for that matter, the Optima QLS, the Century 3000, frankly, even bringing in the ISCO peristaltic samplers, they're all the same. You would have to have a device monitoring the flow and providing information to the sampler, either via 4 to 20 milliamp signal representing 0 to 100% flow rate, or a pulse signal that would represent a fixed amount of volume, one pulse every 100 gallons, or whatever. And as far as the configuration is concerned for all of those sampler models across the board, they're effectively the same. There's some minute deviations in how the configuration is performed from one model to the next, but the fundamental basic is the same across the board. If I have a pulse signal that represents 1,000 gallons and I want to take a sample every 5,000 gallons, regardless of what model number of sampler I have, I program it to take a sample every 5 pulses. If I have a 4 to 20 milliamp signal, and this is where there are some variants, some of the models have the capability, depending upon what peripheral devices you have, where you program in what that 4 to 20 milliamp signal represents, and it does the math on that signal to totalize. And if you've told that unit that my 4 to 20 signal represents 0 to 500 gallons, meaning 4 milliamps is 0, 20 milliamps is 500 gallons, and you tell it I want to take a sample every 2,000 gallons, it monitors that incoming 4 to 20 milliamp signal, and once it totalizes that 2,000 gallon amount, it will trigger a sampler. Some of the samplers with the 4 to 20 milliamp have an interface that converts that signal to a pulse rate, and so therefore you know what each pulse out of that interface represents, and then it's more akin to the programming based upon pulses.
Is there a full bottle detection feature, and if so, how does that work?
The full bottle detection feature would be available for the single bottle units, the composite models. There is a float switch that clips on the bottle, and when it detects the water elevating in the bottle, it will lift the float switch, close the contact, which will inform the sampler that the bottle is full, and it will cease sampling at that point.
Next question is new orders. For new orders, what kind of lead time are we looking at?
To be honest with you, I'm not able to answer that question at this point in time. However, that lead time can vary depending upon how much throughput for orders are in place at any given time. The best answer I have to offer on that question is if you have a desire to know what lead time will be, contact our customer service department. Their phone number is 800-228-4373, and they will be able to give you that information at that point in time, because it does vary from day to day, week to week.
Great. Next question, is there extra equipment or connectors needed to run the flow proportional sampling?
The Teledyne ISCO vacuum samplers do have 2 connectors on the side for the Optima. There is also a connector on the Century, and those connectors are provided with the sampler when they are ordered. And it does require the user to somewhat manufacture the cable, because they would solder the wires to the connector based upon the signal type that they have in place. If it's a 4 to 20 milliamp signal, they would attach the wires to the analog input side. If they have a pulse signal, they would attach the 2 wires to the pulse input. So those connectors are available, and they do ship with the equipment when it is ordered.
Last question we have coming in right now is, will the vacuum samplers work with the sampler output on the signature flow meter?
The signature flow meter does have the output capability to do a 4 to 20 signal. It can do a contact closure via a 304 contact card. So the answer to that question is yes. The signature flow meter can work in conjunction with a Teledyne ISCO vacuum sampler for flow proportional sampling.
And what is the largest intake tubing size that fits these units?
The most common intake tubing utilizes a 3/8 ID intake tubing. It is possible to utilize a 5/8 inch ID line. The issue is that one needs to be aware of is the larger ID line we go with, the lower, more reduced the intake line velocity becomes. So we begin to have a detrimental effect the larger the ID. Technically, we could probably get away with larger, but because of that issue with the line velocity, I would not recommend going with any larger ID than 5/8.
Okay. Well, I think that wraps up the questions for the time being. So on your screen, if you have further questions following the webinar, you'll see contact information for our product support specialist group here at Teledyne ISCO. You can also reply back through the Zoom platform, and I will forward all questions on to Steve to answer. And like you said earlier, he'll be reaching out to everybody through email on their specific questions and making sure you guys have all the information that you need. I did want to let you know our November webinar will be focused on the AccuLink, so be on the lookout for an invitation to that. Will be taking place in later November. This webinar has been recorded and will be available on Teledyne ISCO's YouTube channel later on this week. And you will also receive an invitation to complete a survey after this webinar finishes up. We're always looking for feedback, information you'd like to see covered in webinars, different topics you'd like to see us cover. So please take a few minutes, fill out that survey. We're appreciative of any and all feedback that you provide. So I want to thank Steve for walking through all these questions today, and I want to thank everyone for joining us, and have a great rest of your day.
I also would like to thank everyone for attending and taking time out of your busy day to attend the webinar today, and I wish everyone a great day and a happy Halloween.
Thank you.